Hello to everybody! In this video, we show the solution for a practical case about a robotic system. That system will denominate Master-Slave for the robotic subject in Industrial Technologies degree. Now, let's approach the problem titled Robot to Transport Loads into Warehouses. We have to create a robot that solves the following problem. Carry a load and follow the path of a person in a place, with wide space, as an airport, a train station, etc. It must transport 3 medium suitcases, upload a van conveyor of 2 meters wide, the person would walk for thick spaces, and it must operate safely. About the specifications for the robot, the dimensions of the loads will be 70 cm long, by 40 cm wide, by 25 cm high, with a maximum weight of 100 kg for the master robot and 50 kg for the slave robot. Now, we present the CAD model to explain the proposed solution for our system. This is the master robot, whose dimensions are bigger than the slave robots. This robot can control and coordinate 2 slaves to be displayed later. The location of the slave robots will be displayed through a tablet located in the front panel, whilst slave robots will have a Bluetooth receiver. The tablet will have installed an application shown in the following figure, named Endure LBS. Returning to the CAD model, to follow the person path will be used a Kinect, which faces the person. Security measures will be taken to indicate if the person is lost, there is a sudden change, or more people cross, or in the places with little traffic. Another safety measure will be located on the top of the robot, through a system of infrared sensor located in these holes, and create a mesh to detect if someone is stealing some part of the load. In this case, the robot will stop and beep through a buzzer integrated into the front panel. To manipulate the load, will be used a cover that up or down and provide us introduce the load into the robot, now shown in the CAD model. About the suspension, the model shows how the robot rises escalators. The position of the front wheels and the rear wings will control through linear actuators moving pistons, which are supported on the suspension, and keep the robot in a fully horizontal position. These pistons will have a hole shown in the animation now, with a piezoelectric sensor that will indicate how much the robot must raise or go down. The part of the control is shown at the bottom of the CAD model. It will consist of an Arduino Mega board with a battery and each bridge as a power stage. In the tires, we have brake discs, now active in the video. On the top, finally, there is another motor for routing all the robot. Now we are twisting the CAD model to show that motor. And we can see the motor just in this moment. Here is the movement. Now, there is an accordion part that can be elongated longitudinally and broad the movement of the cover if the load is longer. Now let's close the master robot. Now, here we have the slave robot. This slave robot has dimensions and smaller actuators, so it's cheaper and carry a single charge, which is positioned in this plate, the red plate shown in the figure, and the system is covered and closed. It only have a receiver Bluetooth, monitored using simple commands and off. The architecture of the slave robot is easier. The company of the user can hard the hole depending on the requirements, or only acquire a slave robot or a master robot. This was the exposition about our proposed solution. Thanks.